Imagine you have a twin. Not just a sibling who looks like you, I mean a soulmate, a cosmic twin, someone who is connected to you in a way that defies logic, defies space, and defies time. Imagine that this twin gets on a spaceship and flies to the very edge of the observable universe. They are billions of light years away. If you tried to send them a text message, it would take 1 billion years to arrive. If you tried to look at them through a telescope, you would be seeing them as they were 1 billion years ago. They are gone. They are effectively in a different reality. But now imagine this. You feel a pinch on your arm. And at that exact same instant, not a second later, not a millisecond later, but instantly, your twin on the edge of the universe rubs their arm in pain. You feel happy, and instantly they smile. You make a decision to turn left, and instantly they turn right to balance you out. It doesn't matter that there is a universe of empty space between you. It doesn't matter that the speed of light says communication should be impossible. You are linked, you are one object stretched across the cosmos. This sounds like fantasy, it sounds like magic, it sounds like the plot of a romance novel. But it isn't. It is a real, verifiable, scientific phenomenon. It is called quantum entanglement. And it is the single most disturbing discovery in the history of physics. It scared Albert Einstein so much that he refused to believe it was the whole story. He went to his grave trying to disprove it. He called it spooky action at a distance. He thought it was a mistake in the math. He thought it broke the rules of the universe. But Einstein was wrong. The universe is spooky. The universe is connected in ways that our human brains are barely beginning to comprehend. And if you are ready to understand why distance is an illusion, why you are chemically connected to the stars, and how we might one day teleport humans across the galaxy, please hit that subscribe button right now, because we are about to tear apart the fabric of space-time and see what is holding it together. To understand why this is so mind-blowing, we have to go back to the biggest fight in the history of science. In one corner we have Albert Einstein, the master of relativity, the man who proved that nothing, absolutely nothing, can travel faster than the speed of light. To Einstein, the universe was local. That means things can only affect their immediate surroundings. If the sun disappeared right now, we wouldn't know it for 8 minutes. We would still see the light and we would still feel the gravity because it takes 8 minutes for the information of gravity and light to travel across space to reach us. This is the cosmic speed limit. It keeps the universe orderly. It ensures that cause always comes before effect. In the other corner, we have Niels Bohr and the quantum mechanics. They looked at the math of the atom, and they saw something impossible. They saw that subatomic particles, electrons, photons, could become entangled. This means they share a wave function. They share a mathematical existence. If you take 2 electrons and smash them together, they become linked. Their properties become correlated. For example, electrons have a property called spin. You can imagine it like a top spinning either up or down. The rules of quantum mechanics say that if 2 electrons are entangled, their total spin must be 0. They must balance each other out. So if electron A is spinning up, electron B must be spinning down. That part is fine, that part makes sense. The problem comes when you separate them. According to the quantum theory, until you measure the particle, it doesn't have a spin. It is in a superposition. It is spinning up and down at the same time. It is a cloud of probability. But the moment you measure electron A and find it is spinning up, Electron B instantly snaps out of its probability cloud and becomes down. It doesn't matter if electron B is in the next room or in the Andromeda galaxy. The reaction is instantaneous. Einstein looked at this and said, "No, impossible. That implies that information is traveling faster than light. That breaks relativity. That breaks time." He argued that the particles must have had a secret plan all along. He came up with the gloves in a box analogy. Imagine I have a pair of gloves, a left glove and a right glove. I put them in separate boxes. I mix the boxes up. I send one box to New York and one box to Tokyo. I don't know which is which. But the moment I open my box in New York and see a left glove, I instantly know that the box in Tokyo contains a right glove. Did I send a signal to Tokyo faster than light? No, the gloves were always left and right. I just didn't know it until I looked. Einstein called this hidden variables. He said the electrons were like gloves. They knew their spin all along. We just thought they were in a sewer position because we are ignorant. He basically said God does not play dice with the universe. Reality is set. For decades, everyone thought Einstein was right. It made sense. It saved the laws of physics. But then came a physicist named John Bell. In the 1960s, Bell realized that there was a way to test this. He created a mathematical formula, Bell's inequality, that could determine if the particles were like gloves fixed from the start or like magic coins decided in the moment. He proposed an experiment. And when scientists finally ran the experiment in the 1970s and 80s, the results were shocking. Einstein was wrong. The particles were not gloves. They didn't have a hidden plan. Before they were measured, they literally had no defined spin. They were truly, genuinely undefined. And yet, when one was measured, the other knew. It is as if you flipped a coin in New York and it landed on heads, and at the exact same moment, a coin in Tokyo, which was still spinning in the air, was forced to land on tails. The coins communicated, they synchronized, without any wire, without any signal, without any time passing. This is the mystery. This is the spookiness. How does the second particle know? If space is real and if the speed of light is the limit, how does the information get there? This brings us to the modern understanding of entanglement, and it forces us to question the nature of space itself. Many physicists now believe that entanglement shows us that distance is an illusion. We think of space as a big, empty stage where things sit apart from each other. But entanglement suggests that the universe might be more like a hologram or a projection. Imagine a fish swimming in a tank. Now imagine two video cameras pointing at the tank. One is pointing at the front of the fish. One is pointing at the side. These cameras feed into two separate TV screens in the next room. You are sitting in that room watching the screens. You see two fish, one on the left screen, one on the right. When the fish on the left screen turns, the fish on the right screen turns at the exact same time. You might think, wow, these two fish are entangled. They are communicating instantly. But they aren't communicating. There are not two fish. There is one fish. You are just seeing it from two different angles. Entanglement might be telling us that the two electrons on opposite sides of the universe are not actually separate. They might be connected by a wormhole, a tunnel through the fabric of spacetime that connects them directly. Or even wilder, they might be the same object, just projected into our 3D reality in two different places. It implies that underneath the reality we see, underneath the separation of me and you, there is a deeper layer of reality where everything is one. Now let's move from the philosophy to the practical, because this isn't just theory anymore, we are building technology with it. Welcome to the world of quantum teleportation. When we say teleportation, you probably think of Star Trek. You think of beaming a person from a ship to a planet. We aren't there yet, but we are doing something just as incredible. We are teleporting information. Here is how it works. Imagine Alice wants to send a photon, let's call it photon X, to Bob, but she cannot send the photon itself. She wants to send the state of the photon, the information that makes it unique. Alice and Bob share a pair of entangled photons. Let's call them A and B. Alice has A, Bob has B. Alice takes her mystery photon X and interacts it with her entangled photon A. She performs a measurement. This measurement destroys the original state of photon X. It is gone. But because photon A was entangled with photon B, the information from X is transferred into the entanglement link. Bob, on the other end, performs a manipulation on his photon B. And suddenly, photon B transforms. It takes on the exact state of the original photon X. The photon didn't fly across the room. The information simply disappeared from Alice's location and reappeared at Bob's location. We have successfully teleported the quantum state of a particle. Scientists have done this over miles. They have done it from the ground to a satellite in orbit. This is the foundation of the quantum internet. Imagine an internet that cannot be hacked. In a normal internet, if I send you an email, a hacker can intercept the signal, copy it, and read it. I would never know. But in a quantum internet, the information is sent via entanglement. If a hacker tries to look at the message, they have to measure the particles. And remember the observer effect. The moment they measure it, the wave function collapses, the entanglement breaks, the message destroys itself. It is the ultimate security. It is physically impossible to spy on a quantum transmission without destroying it. But let's take it a step further. Could we ever teleport a human? A human is just a collection of atoms, a lot of atoms, about 7 octillion of them. If we could scan every single atom in your body and entangle them with a reservoir of atoms on Mars, we could, in theory, transfer your quantum state to Mars. But here is the catch, the terrifying catch. Quantum teleportation requires the destruction of the original. To teleport photon X, Alice had to destroy it. So if we beamed you to Mars, the you on Earth would have to be vaporized, you would die. And a new you, constructed out of the atoms on Mars, would wake up with your memories, your personality, and your body. Would it be you, or would it be a copy? Would you have died on the pad in New York? Would the person on Mars be an imposter who thinks they are you? This is the teleportation paradox, and quantum mechanics tells us that we cannot have our cake and eat it too. You cannot copy quantum data, you can only move it. So if you want to travel the stars via entanglement, you have to be willing to die at the departure gate. But there is a deeper, more emotional layer to entanglement that I want to leave you with. It brings us back to the Big Bang. 14 billion years ago, the entire universe was compressed into a singularity, a point smaller than a single atom. Every piece of matter, every photon, every electron that currently exists in the universe was trapped in that tiny space. They were all touching, they were all interacting, they were all entangled. Then the Big Bang happened, the universe exploded outward, things flew apart. Galaxies formed, stars formed, planets formed, you formed. But quantum mechanics suggests that once particles are entangled, they remain entangled until something interacts with them to break the link. This means that, on a fundamental level, you are entangled with the universe. The atoms in your left hand might be entangled with atoms in the center of the sun. The atoms in your eyes might be entangled with atoms in a nebula a million light years away. And the atoms in your body are certainly entangled with the atoms of the people you have interacted with. Have you ever felt a connection to someone that you couldn't explain? Have you ever known someone was in trouble before they called you? Have you ever looked at a stranger and felt like you knew them? Science calls this coincidence, but maybe, just maybe, it is the residual echo of the Big Bang. Maybe it is the physics of entanglement playing out on a biological level. We feel alone, we feel small, we feel isolated in our separate bodies, living our separate lives. But physics tells us that separation is the lie. Physics tells us that at the deepest layer of reality there is no here and there. There is no me and you. There is only the whole. We are a single shimmering web of energy, stretching across space and time, pretending to be separate pieces. Einstein called it spooky. I call it beautiful. It means you are never truly alone. It means you are never truly disconnected. It means that when you look up at the stars at night, you aren't looking at something foreign. You are looking at your family. You are looking at the rest of yourself. This is the mystery of quantum entanglement. It breaks the rules of space to preserve the rule of unity. It challenges our logic to comfort our souls. We are just beginning to scratch the surface. We are building quantum computers that will solve problems in seconds that would take supercomputers a million years. We are building unhackable networks. We are probing the nature of black holes. But the biggest discovery is the one we make about ourselves. We are quantum beings. We are vast. We are connected. If this journey into the spooky side of physics blew your mind, if it made you look at the world a little differently, please hit that like button. It helps us entangle with more curious minds out there. And if you want to explore more of the impossible questions, from the nature of time to the simulation theory, hit subscribe. We are going to keep diving deep into the rabbit hole, and I want you there with me. Let me know in the comments, if you could teleport to Mars but you had to be destroyed on Earth, would you do it? Is the copy you? I'll see you in the next reality. Stay entangled.